Hi, everybody. Okay, we're kind of wrapping up the object-oriented principles here in Java with object-oriented concepts. So we talked about inheritance, we talked about um, interfaces, so composition. We've talked a little bit about encapsulation, hiding implementation inside of a class. Now we're going to talk about the object-oriented concepts that hope that we bring it more together. And then in the next lesson, we're going to actually build something with everything we've learned, because this is really the last thing we need to learn here to be effective in Java. And we can start creating some pretty good programs with what we know already. And there's not really much more as far as the language is concerned to learn. You'll have to learn some specifics about some things that you want to do. But at this point, after this lesson, you have all the basic tools you need. So basically, you have all the Legos you need to build pretty much anything you want. Okay, so here we go with classes. So a class is the definition of something. You've seen this already. But we're going to talk about it in object-oriented terms. If you're going for a job and they ask you about object-oriented principles, this is going to tell you some of the answers. Okay, so a class has properties and methods. Okay, and we've seen that already. Properties are the member variables, and methods are functions that you can call. They either return something or they don't. And so that's how a class works. They have logic inside, so they encapsulate the information. So you don't see the implementation. You just say, I want this thing to do something. And you don't really know how it does it. It just does it. You might know how it does it, but it's not important to your program. Your program just calls that method signature, and then it'll do what you expect it to do. If they do an update to the program, you don't expect your program to break. And that's how classes work. So let's use an example. Lion King's a good one. So we've got Simba, and he's an instance of a lion, right? We talked about lion and mammals before. And Simba has properties. He's got a name. His name's Simba. His age, he's 1. And his size, he's small. He's not full grown yet. And then there's Mufasa, who's also an instance of lion. And his properties are his name is Mufasa, his age is 12, and his size is big. Okay, so the methods for all lions are the same, right? The class lion is all the same for everyone, but the instances are different. So for all lions, they can run, they can sleep, and they can roar. And so as instances, we can instantiate them this way. So we're going to go ahead and do Simba, and that's his name, there's his age, and there's his size, and then Mufasa, 12 and big, right? Okay, so now we can make Mufasa roar by calling his roar function, and we can make Simba run by calling the run function. Okay, and so with inheritance, we have that going on. We don't have the breathe method inside of the lion class because it's actually inside of the animal class or mammal class. It depends on how deep our hierarchy is. You only want to abstract what you can. So you know how the animal kingdom phylum thing works, probably in general at least. It's a pretty deep hierarchy. In your program, you don't want to go and implement all of that. You only need to implement what you need. So if you have a class that you implement and you see an abstraction, and that's another object-oriented principle, you're just going to make a base class and pull some stuff up in common. So that way you have, say, 2 instances of something. So let's say we've got a lion and we've got a cheetah, right? So cheetah is a different class and lion's a different class, but they both inherit from mammal would be, say, our next one up, or land animal or something. We only want to implement one level up unless we have a need to go higher. So we're only going to go as high as we need to go. And then anything that's in common, which sounds like a lot. I don't know if cheetahs can roar. Lions typically roar, but cheetahs can definitely run, and they can definitely breathe. So we can pull those up into the whatever we call it. Let's call it animal class, or we could even call them cats at this point. And we could pull that up there. And then the roar is what a lion has, and cheetah might not have anything special because they can run, but then in another object-oriented principle we'll talk about, they can run really fast, which is different than how a lion runs. Okay, so here are some of those terms that we're going to talk about now. All right, so there are 4 main terms in object-oriented. Now remember this, because if anyone's asking you a question in an interview, they're going to ask you, if it's about object-oriented, they're going to ask you what are the 4 tenets or the 4 attributes of object-oriented programming. And so polymorphism is one of them, and that's what we were just talking about with the cheetah versus the lion. Both of those animals can run. The implementation is different for a cheetah. A cheetah can run really fast, and a lion doesn't run as fast. So that's called polymorphism. We've got an animal, and in this case, we're talking about a land animal. So we say, okay, I've got this land animal, happens to be a cheetah. I'm going to call the run method on that land animal, and it's going to go really fast. I'm going to call that same function on a lion. It's not going to run as fast. So that's polymorphism. The same function acts differently depending on the class. Okay, so, and a tortoise, of course, is going to go really slow. I don't even know if you could call tortoise a run, but maybe we can. All right, now abstraction is the art, I'm going to say, of looking at the commonality between classes and figuring out what can be pulled up or abstracted into a parent class that each of these can extend or implement as far as composition is concerned. So that way you reduce duplication, because if you have duplication and you have a breathe method in your lion and you have a breathe method in your cheetah or tortoise, and they should be the same function, and you need to change it because, wait, I learned something new about breathing that I have to implement, you're going to have to implement it in two places, where if you pulled it up into a superclass or the parent class, you'd only have to change it in one place, because not just tortoise and lion are going to implement animal. It's going to be elephant, it's going to be giraffe, it's going to be all those, and you don't want to change all of them. So you want to abstract things up to a common base class as much as you can to reduce duplication. So as soon as you have two things, you want to start looking at reducing duplication. And that's how that works. So encapsulation we talked about before, that's where you're hiding the implementation or the data, so you can go ahead and make changes without breaking the world that's using your class, your library, whatever you end up making. And then inheritance we've talked about, of course, before. It's where something can extend whatever this other class is, so it's adding new functionality to it, and that's inherited. So the four basic principles are polymorphism. It's allowing the implementation to be different for the same function among different subclasses of a class, right? So land animal can just be called its run method, and then depending on what it actually is, a cheetah or a lion or an elephant or a tortoise, it'll just run the way that it's programmed to run, which is polymorphism. Abstraction is being able to actually pull up those common things into another class, so that way you can maintain it a lot easier and do the implementation in one place where it is then used throughout the hierarchy. And then encapsulation is where you're hiding things. This is just a summary overview of what we just went over. And then inheritance is where you can extend a class and add functionality to it. Okay, that's the end of the learning part. Well, actually, it's never the end of the learning part. You'll always be learning. But it's the end of teaching you Java principles in programming. Now, remember, these principles transfer to other languages. So learning them here is definitely beneficial to you, because you'll use them in any other language. If you learn C#, very similar language, all the principles are the same. In fact, the code is very much the same. The syntax is almost identical, some minor differences, some library differences, but other than that, they're pretty much the same. We're going to do a few exercise lessons after this, build some programs with everything you've learned. At this point, you know enough about Java to build pretty much anything you want. Anything else you need to learn, you just consult whatever documentation of the library you want to use is, or even Java's has a lot more built-in classes than we've covered here. But you have all the basic tools now to make whatever it is that you want to in Java. And we're going to make a few of those programs in the next few lessons. All right, thanks for watching.